a model quiz. Question 1 has eight things that you have to explain. The first one is 1A. Oh, let me see. Will everybody turn the video on so I can see your faces? Hi, Swasti, Tanish, Sriram.
Hi, sir.
Saicharan, Vinay, Srinandan, Pragyan. Put on the video, Pragyan, Divyan.
Sir,
all right. Tomorrow in the office hour, you will take the model quiz. And the first question will be exactly as you will be taking the actual quiz. This is the model quiz. But tomorrow, the first question will be exactly like in the model. So you will be asked to state Aristotle's law of thought. There are 3 laws. These laws govern the thinking that people usually do. And anybody knows what the first law is? What is Aristotle's first law? Srinandan.
Law of non-contradiction.
No. Try again. Someone else. What is Aristotle's first law of thought? Good. So I'm glad I put it on the model quiz.
Law of identity.
Okay. You must remember it the rest of your life. This is very important stuff. Aristotle's first law is the law of identity. It is a very intriguing law. And what is that law? All you have to do is say A equals A. Everything is itself. That's very interesting. How can you really adequately describe something? You can't. A cow, how can you describe a cow? All you can say is a cow is a cow. That is precise. Now, I told you about this poet, Gertrude Stein. She, not a mathematician, explained this law best.
Rose is a rose.
Is a rose
Yes.
is rose.
She was describing a girl by name Rose. What was her name? And she wrote, rose is a rose equals rose is a rose. Saying that this girl Rose is like the flower, rose is like you're saying the flower rose is a rose. Isn't that beautiful? Not a mathematician has explained it so well. A equals A, that's what it is. Well, this is poetry. She didn't say equal. What did she say?
Again, she said
Rose is a rose. Is a rose is a rose. See, you guys can understand that poem. When people read it, they will have no clue what this lady is saying. Understand? This is the law of identity she is talking about. Rose is a rose. Don't even bother saying that, because the poet is saying, of course, rose is a rose. You understand? So it is in a way telling us about the law of identity, but you don't have to write all this tomorrow. What do you write? Tomorrow, all you have to write is this stuff. Are you happy? Will you know what the law of identity is? You can read about it more. This is philosophy, okay? And mathematics is its own philosophy, okay? And what's the second law? Yes, two participants. Who wants to talk?
Shridhara, why don't you answer?
Yes,
Law of non-contradiction.
Ruhi, paraphrase.
He said law of non-contradiction.
Oh, yes. Sorry. Yes, indeed. Well, it's so big, so long to write it. People call it LNC, law of non-contradiction. This is considered to be the basic law on which mathematics sits, law of non-contradiction. So tomorrow you have to say this, and then you draw this diagram. If this is A, this is not A. A is a statement, a declarative statement. Namely, what is a declarative statement?
Sir, but that is on.
Or
It is
excluded
either
middle.
true or
Yes, sir.
Excluded
So that
middle,
comes
right?
in the excluded middle,
either
right?
true or false. Like Ganges is in America. Is that a true statement? It is false, right? This is a declarative statement. Okay, on the other hand, well, I better stop right there. We did it. These are in your notes. Tomorrow, all I need from you is this. This says that the intersection of A and not A is empty. There is nothing. They don't intersect. You follow? Something and not something cannot be true at the same time and in the same sense. This is the picture I am looking for. Is this clear? This says that A intersect, not A is empty. They don't have anything to do with each other. So, is this diagram confusing to you, Manas?
No,
Does
sir.
it mean, do you understand the diagram?
Yes, sir.
How about you, Vihan? Do you understand this diagram?
Yes.
Okay. So, and the last one is Sasha.
The no middle one. I don't remember the name, but excluded middle.
Law of excluded middle. And again, you have to show a diagram. It essentially means that
Same
there
one.
is not, this middle is excluded, right? So the diagram now becomes what?
Two squares.
It is A and not A. There is nothing in the middle. The middle is excluded. There are only two choices because these are declarative statements, A or not. So this is what I am looking for an answer. Do you understand what is going on?
Yes. Yes.
Everybody is happy. When are you happy?
Yes, sir.
Can you explain this to someone? Aristotle's laws.
So the first law of Aristotle states of identity means A is equal to A. You cannot compare A with B. A will not be equal to B. A will only be equal to A. Then in law of non-contradiction, it is that A and not A do not have anything in common. Their intersection will be an empty set. And for law of excluded middle, there will be no
Right.
middle.
Now, what's the difference? Excellent. What's the difference between these two? Here, A intersect A is not empty, is empty. A intersect not A is empty. How about here? Here also it is empty. What's the difference between these two diagrams? Here there is no Srinandan.
Sir, in the diagram for non-contradiction, there is a set in between, but for excluded middle, there is no set in between A and not A.
There is no third choice. Now, so this is your answer. Can I go on to B now? 1B. 1B is Frege's identity. And what is that? Tell me, Frege's identity. Vanya.
P implies Q.
P implies Q. What about it? That is equivalent to some other statement. What is it?
Sir,
Not P and Q.
Identity means there is some, it's an equation. That means not P or Q. Frege came up with this idea. That is because, so this is the answer I am looking for. We already explained that in the class and it is in the notes. Can we go on to the next one?
Yes, sir.
So, see, you can memorize it and remember it. Remember it whenever you need to. This is a very useful identity. We'll go to C. See, this is the, for example, I must mention this before I go. You know, when you make a truth table, you have P, you have Q, you have P implies Q. What is not P or Q, let's say? So true, 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 false, false, true, false, false. True implies true is what? Does true imply true?
True.
True.
True implies false.
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 Truth doesn't imply false. Now we have a problem. False implies truth? Well,
We don't know.
You don't
we
know.
don't know. False implies false. That
We
is
also
where
don't
this
know.
comes in handy. This comes in handy. Go to this column, then we can fill this in. What does this say? If P is T, not P is false, false or true is what?
True.
And opposite of this is false. False or false is...
False.
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 Let's try this one. Opposite of P is true. If that is true, then we don't even have to worry about the other one because this is inclusive or. And what about this one? Opposite of this
True.
is true. Aha, this is helping us fill this column. True, true. Now we can say confidently that false implies true is a true statement. Okay. If for example, let 3 equals 2 and square root of 2 is rational. Is this true, the statement?
No.
False. Is this true?
False.
False. Is this statement true? If 3 equals 2, then square root of 2 is rational. Is that statement true?
It will be false. Because the square root of 3 is also irrational.
That is a true statement. If 3 equals 2, 3 is not 2, so this is not violated. Are you with me? This is a true statement. And that follows this thing here. Think about it. Anyway, we don't need any of that stuff tomorrow. It's all in your notes.
Do we have to draw the truth table tomorrow or do we not have to?
No, you don't have to do anything. This is all I am asking.
Okay, sir.
Sasha, this is Frege's identity. Don't worry about anything here. I think
Yes.
I talked too much. So tomorrow, this is what we need. Then C, 1C is De Morgan's laws. And what are you going to write there? It has to do with the complementing. P or Q. Pragyan, tell me what that is.
Yes, sir. De Morgan's first law was not bracket P and Q is
And
equal
Q.
to not P or not Q.
And this one is
Not P or not Q.
not P or not Q. And that is all I need from you. Okay? De Morgan's laws. This is something you need to carry with you. Okay. And 1D will be what? Suppose you are given P implies Q. What is the contrapositive? What is it? Behind.
Not Q implies not P.
Everybody better know this from now on. And E, what is the inverse? By the way, we said to prove P implies Q, it is sufficient that you prove this one. Why? Because if P implies Q is true, what is it? If this is true, we know not Q or not P must be true, which is not P or Q, which is P implies Q. Wonderful. So if you prove it, S6, tell me. I'll be right back, guys. Need to get me a kerchief. Good. Question. Who has a question? Anybody has a question? You, 6 people had raised their hands. Let me go to E. So I am assuming you now can remember A, B, C, D. These are basic foundation. Raunak? Raunak,
Yeah.
I can't see your face. Okay. Let's go to 1E. Modus ponens, the most useful rule of inference. Okay, tell me modus ponens. 2 participants. Okay, who wants to say?
Sir, I think we missed inverse of P implies Q.
Oh, I did. I sure did. So let's put inverse here. I'll go back to the
Sir, that
previous
is also
slide.
labeled as D.
Oh, there is no
Yes, there are
space.
two labeled as D.
So I'll put it there. That is there. 1e. What is the inverse of P implies Q?
Not
Yes.
P implies not Q. Not P implies not Q.
Where I live in Canada, it is a springtime and lot of flowers, lot of pollen, and sometimes I get an allergy. But I'm one of these health nuts. I don't take any tablets, so I just suffer it. When I get a headache, I don't take any pills. I don't like medicines, unless of course we have a serious situation. So I never take medicine or any tablet. So my allergy will stay with me for 10 minutes, then it will go away. Inverse of P implies Q is not P implies not Q. Question. So this is what you need to answer tomorrow. So your answers are short for the question. I want to ask you, just because P implies Q is true, does it make the inverse true?
No, inverse doesn't always have to be true. It can
It
be
is not
false.
always true.
Very
Yeah.
good.
Can be true or false.
But we know that P implies Q is equivalent to this. Excellent. We go to the next one. The next one is modus ponens, I said. The most important rule of inference. And what does that say? Who can tell me what that is?
Ishan, you want to answer?
Modus ponens. Yes.
Pragyan?
Sir, when P implies Q, if we know P is true, then Q has to be true.
That's what I'm looking for you from tomorrow. Tomorrow. For that question, I'm looking for from you this. This says that if you can prove this, for example, if sun shines, Sai go to beach. P implies Q, okay? If sun shines, then Sai goes to beach. So if this is true, does it mean that Sai is at the beach now? What will make this true? What will make Q true? The sun must shine. Ah, now I know. Where is Sai? She's at the beach because it is true that the sun shines. Just because this is true doesn't mean Sai is at the beach. Is that clear, Vanya? Vanya.
Yes, sir.
This is modus ponens. P implies Q may be true. That doesn't mean Q is true. This is clear. We had.
Yes,
Sasha.
clear.
Sasha,
Yes, sir.
is this clear to you?
Yeah.
This is modus ponens. Now, so this is the answer I am looking for. While I am here, let me show you, let me tell you about something. This you don't need tomorrow. Ishan,
Yes. I have a doubt. What have you written? I have a doubt. What have you written under P implies Q?
you are saying, suppose you have P implies Q and you have Q here. Is P true? Is that the question?
My question is, is under that P implies Q? The part by which you have written that, what is that?
Ruhi, paraphrase.
Yes, I think he's asking what is the P slash and then Q? Like, what does that represent?
Oh, this slash. Oh,
Ishan,
that is simply short. I mean, I didn't want to write too much. It says, watch this. If P implies Q true and P true, then Q true. Which one you want? This statement or a way of representing?
Okay,
This is
okay.
fast, isn't it? It's only a way of saying, this is what I am saying. This is only a way of representing this sentence. Is that clear?
Okay, thank you, sir. 1 second.
Okay.
excuse me, sir, your 24
Is
minutes.
that your question?
Yes.
Yes. P implies Q. And if you give me, tell me P is true, then I know Q is true. That's what this is. That is this sentence. From you, tomorrow, it is better to write like this because it is less chance for going wrong. You know, you must put Q there. You see, in logic, we cannot go into that direction. This is called detaching P away. P is gone. Now Q is true. Before I leave this part of the quiz, I want to ask you, some people confuse the law of the modus ponens with this. That is wrong. Let me give you an example. If the bulb is broken, then the room is dark. So P implies Q. Agreed? Suppose somebody says this, Q is true. What? So what does that mean?
The room is dark.
The room is dark. Can you imply that the bulb is broken?
Because the bulb might
You can
be
just
switched off.
Yeah, you can just
Just
keep
because
it
the room
switched
is dark. Room can be dark due to various causes, right? One of them is the bulb is broken. Surely the room is dark. Maybe somebody didn't plug in the lamp. Maybe somebody didn't turn on the switch. Maybe the switch is wrong. Just because the room is dark cannot imply that P is true. Agreed?
Yes.
This is false. This is false. That's a fallacy. This is true. This is modus ponens. You can see that this is true. Oh, let's
Do
go
we need
back
to
to
write its notation also?
yeah, you give it to me like this.
excuse me, Dr. Thomas.
Yes.
24 minutes time is up.
Oh, the time is up now?
Yes, 24 minutes for the first question only.
Oh, okay. I better move on. I still have two questions, well-ordering theorem and well-ordering principle. This is that every set can be well-ordered. That means every subset under that ordering has a what?
smallest element.
Smallest element. This applies to which set? This applies to every set. This applies to what set?
Second to
Natural numbers. Okay? So this is well-ordering theorem applied to natural numbers. In particular, we find that the standard order a less than or equal to b, if and only if b minus a greater than or equal to 0, is a well order. That means under this order, so that's what I'm looking for tomorrow. Ruhi, I am quitting now. Going to problem number 2.
Can you show the slide before slide? Okay, thank you.
Problem number 2 is, suppose I tell you n is a positive, n is an odd integer, positive let us say, implies 5n plus 3 is even. Suppose we have a statement like that. Let us prove it 3 ways. A, direct proof. Who wants to do it?
Can I do it?
P implies Q. In a direct proof, all you have to work with is what?
P.
P. You can also try not Q implies P, not P, in which case all you have to work with is just this. In a direct proof, you have only one assumption, one hypothesis. So, Ruhi, can you get someone? 3 people raise the hand.
Ishan, why don't you answer this?
Yes. Do the problem.
Yes. By which method do I have to answer this question?
Which one of the 2 direct proofs do you like to use?
Contradiction.
P implies which one?
Contradiction.
He said contradiction. But Ishan over
No,
here.
no. We haven't come to contradiction. We are talking about direct proof. In direct proof, there are 2 methods. That is, P implies Q or not Q implies not P. Either one will do. Ruhi, get me another.
Vinandan,
One of
why
our-
don't you answer?
Sir, so if any odd number can be expressed as 2n plus 1.
So are you choosing this version or this version?
P implies Q.
Okay, let's do P implies Q. So we will take P and it says n odd.
Yes, sir. So any odd number including n can be expressed as, let's say, 2k plus 1. When if you multiply, then if you plug in 2k plus 1 in 5n plus 3, you say 5 into 2k plus 1 in plus 3 equals, then if you simplify, you get 10k plus 5 plus 3, it's 10k plus 8. Because 10k is 2n for some integer. I mean 2p for some integer. Yeah, 2 into 5k plus 4. So it is 2 into. So it is
Done.
divisible by 2. Therefore it's even.
You are finished. I put a symbol here. What do you call it? Mathematicians put something after their proof. This is called a tombstone. They got this idea from magazine articles. At the end, they have a square. Mathematicians put a tombstone or even a square. And what does a tombstone signify? It shows
Rest
that
in
somebody
peace.
is dead. What is dead here?
It's over. The proof is done.
Any doubt about the truth of the proof is dead. That is why you have this tombstone here. We proved it. The proof is finished. All right. So, tombstone. Good. We proved it directly. Excellent. We could also prove it counterpositively. But I didn't ask you for that. Now let us prove the same thing by contraposition. Okay, someone else. Come on.
Vanya.
Yes.
No, I was answering for the direct proof. I'm a little confused how to do it by contraposition.
Contraposition. Oh, I'm specifically asking for it. Oh, okay. So do it. Srinandan. So not Q.
So if you take not Q is that 5n plus 3 is odd.
Everybody agrees? Swasti, do you agree?
Then 5n.
Not Q.
Yes, sir.
So what do we do now? If it is odd,
Then n must be even because any then n
this
must
can be, if this
yeah
is
n
odd, this can be written as 2k plus 1. Is that right?
if this is odd, the 5n plus 3 can be written as
Does everybody agree?
yeah.
Yes, sir.
Yes. And then what? 5n is equal to 2k minus 2. Is that right?
Yeah.
So that means that this is 2 times k minus 1.
So it is even
So why should it be even?
because it is 2 into something.
Well, it is 2 times something. 5n is even. How about n?
If 5n is even, n is even.
There you can say that, but you are using a lemma called Euclid's lemma, but you don't have to worry about it now. It's actually in my notes. If a prime divides, if 2 divides 5, if P divides AB, P divides A or P divides B. That's famous lemma called the Euclid's lemma. So 2 divides 5n. Does 2 divide 5?
No.
No.
So
Therefore, 2 must divide.
n.
Therefore, n is
Even.
n is even. You got the opposite of that. Therefore, we got the opposite of that. Therefore, the actual n is odd, isn't it? Not Q implies not P. We got that n must be even. Therefore, n is even will stand for not P. We want P. Therefore, n is odd.
Sir, what did you do after the step 2 bracket k minus 1?
Let's stay on this problem. Let's not go anywhere. Very important. And Ruhi, what was that comment?
He was asking what is there after the brackets.
What?
That-
Say that again.
Pragyan, please.
What did you do after 2 bracket k minus 1? I mean, what
Oh,
did...
what I did
Lemma.
after this.
Yeah.
Dr. Thomas, this is Vinay here.
Yes.
If I understood Pragyan correctly, he is asking after this statement, how did you argue the case?
Yeah, that's right. So we have 5n. I was not going to quit this problem. We have come this far. Everybody is together on this. Does this mean 2 divides 5n? Yes or no? 5n is 2 times something. That means 2 divides 5n. That's the definition of division. 5n is even, it says. Agreed? 5n is even. Why? Why is 5n even?
Because 2 divides 5n.
Yeah, because 5n is 2 times something. So, can I say this? If 5n is even, 2 must divide 5n. Who agrees with that?
I agree.
You see, 8 is even. Why? Because 2 divides 8. A number is even if it is divisible by 2, isn't it? If you can divide by an integer by 2, what do you call that integer? An even integer. So we find that 2 divides 5n. An even integer is divisible by 2. That is not a big math, is it? 2 divides 6, 2 divides 18, 2 divides any even number. That is the definition of an even number. So do you agree with this? That if 5n is even, 2 divides 5n. Swasti, do you agree?
Yes, sir.
You don't agree? You guys are confused because I talk too much. Aditya. Aditya,
Yes, sir.
can you explain to people why this is so?
Yes, sir. So we see that 5n plus 3 is odd.
No,
So
yeah, just from this step, how did we get here?
we divided both equations by 2.
No, actually, not quite. You have to ask yourself, what does this step mean? What does this tell us about 5n?
Sir, I got my answer for that.
2 multiplied by k minus 1.
Wait, but so what does this equation tell us about 5n? What kind of integer is 5n? It is because it is 2 times something. 5n is an even number, isn't it?
So it needs to be divisible by 10.
Yes or no? Is this an even integer?
Yes, sir.
Why?
Because it's divisible by 2.
It is 2 times something, isn't it?
Yes, sir.
It is 2 times an integer. That is why 5n is an even integer. Every even integer is divisible by 2. Do you agree?
Yes, sir.
Now, Euclid's lemma says whenever you have a product divisible by a prime number, either P divides A or P divides B. Now, does 2 divide 5?
No.
Therefore, 2 divides n. Okay? So we have reached, according to this, not P. So if contraposition reaches not P, if contraposition reaches not P, that means P implies Q is true. Agreed?
Yes, sir.
So we have used the contraposition to prove this. Yes, let me take the question. Ruhi?
Yes, sir.
Who is Ravana, turn on your video. Sasha, turn on your video. Jai, turn on your video if you can. Maybe you have internet problem. If you can, turn it on. I need to see your faces. 3 people raise their hand. Who wants to talk?
Pragyan, why don't you answer?
Pragyan.
Oh, okay. Pragyan lowered his hand. Shriram, why don't you answer?
I have a doubt.
Okay, ask me.
Yeah, so isn't contraposition like contradiction?
No.
Here
we are coming to contradiction. You see, actually, Pragyan. This is Pragyan?
I'm Shriram.
Shriram. Contraposition is not contradiction. Contraposition is a direct proof. Just like that. It is to make sure. It is to make sure that you are happy with it. You know it, that we are doing this quiz. This is not contradiction. This is We assume not Q and you got not P. You got this? You got, this is like an A implies B. Are you with me?
Yeah.
There is no contradiction here.
Yeah,
If
but
you
here
get,
we are getting 2, n is divisible by 2. But
yes,
in the definition we are getting, we are told that n is an odd integer. So isn't this a contradiction?
no, we haven't reached a contradiction. You see, what we have done is we assumed the opposite of this and we got the opposite of that. That means what we did was this. Do you all agree that what we did was not Q implies not P? What was Q? 5n plus 3 is even. What is the opposite of that?
5n plus 3 is odd.
Odd. You are taking quite a long time to say that. Thank you for saying that. You came through. This is the opposite. This is not Q. Not Q. Not Q. Clear? Swasti? Swasti. This is clear that we are assuming not Q.
Yes.
Oh, okay, I got it.
We have to assume not Q, and we got something. Whatever you got is not P.
Yeah,
Therefore, you have proved P implies Q. Clear?
Yeah.
You see, sometimes it is easier to take this form and do it. Sometimes this form. We found that going this route was harder, wasn't it? Going this route was easier. We did both only to show you the difference. Are you with me?
Yes.
This was harder, but we did it to show that there is another way of doing the same thing. And finally, the third part of it was, now we come to what? N odd implies 5n plus 3 even. We prove by contradiction. Proof by contradiction. Now we are coming to proof by contradiction. We are sitting at the very core of this course. We must understand P implies Q method, not Q implies not P method, and proof by contradiction. And for proof by contradiction, what is the implication we are trying to prove? You must tell me that.
Have to show not P implies Q.
You are again assuming not Q. Anything else?
Not Q, comma P implies contradiction.
Yes. Not it. Now you have two things to work with. That is why, tell me, why is proof by contradiction so efficient?
Because I have two things to work with.
Why is proof by contradiction so efficient usually? Why? Because you have, how many things do you see here?
2.
How many things you see here?
1.
In proof by contradiction, you are assuming two things to get what?
Contradiction.
Contradiction. You have two things to work with. Let us see. So we assume n odd. What else do we assume?
5n plus 3 is odd.
5n plus 3 is odd. Ah, that's very interesting. Let us, and by assuming both of these, what should happen? We should come to a
Contradiction.
contradiction. Can one of you do this now? Or you tell me and I will be your scribe.
Tanish, why don't you answer?
Ruhi,
Yes.
select one person.
Yes, Tanish.
Yes. So like we have assumed that 5n plus 3 is
No,
odd.
Tanish, I can see that you got it. Get somebody else.
Okay.
Swasti.
Yes, so if n is odd, then 5 into n will also be odd because 5 is odd, so odd into odd is odd. And we know that 3 is odd, so odd plus odd is even. And a number cannot be even and
So,
odd.
okay, what should be my first line on the proof?
So 5n, so since n is odd, 5n will be odd.
Well, I need to write algebra. What should be my first line?
N is equal to 2k plus 1.
N equals 2k plus 1. So we are using this here. And then what?
Now we substitute 2k plus 1 and 5n plus
5, 2k plus 1 plus 3 is what? It's supposed to be odd, is odd, right?
Yes.
So let us see if it is odd. That's what they are saying. Is it? Expand this.
10k plus 8.
10k plus
Plus 8.
8. Is this odd?
No, because we can take 2 out.
That's even.
Yeah.
That's a contradiction. 10k. Well, what does it contradict? Let's see what
We are saying that 10k plus 8 is odd, but our result is 10k plus 8 is even. That's contradiction.
Yeah, this is supposed to be odd, but it turned out to be
Even.
even. That's a contradiction. This cannot be odd and even at the same time, can it be?
No.
It violates the which law does it violate? Law of non-contradiction. Law of excluded middle, sorry. So there is a contradiction. Something cannot be odd and even at the same time. Therefore, n must be, oh, we have a problem. Which one do we change?
We need to prove that if n is odd.
We don't have to worry. As soon as you reach a contradiction, we know that therefore P must be the assumption of not Q is wrong. Therefore, Q is right. And what is Q? 5n plus 3 is even. I'm not happy. Let me write it again. This is the core of our course. N odd implies 5n plus 3 even. Proof by contradiction. So P implies Q. So assume P and not Q. So N odd. What else? What do I write now? Saicharan. Saicharan, I would like to help me to do this proof by contradiction one more time.
Yes. So could you
This
please
is Q,
repeat?
this is P. So we know I put P here, N odd. Now you put this guy here. What is it?
Even.
Q is this. This is Q. What is not Q?
Okay, yeah. So 5n plus 3 is odd.
Okay. And somebody else wants to work with me on this?
Manas, why don't you try?
Who wants to work?
So, can I answer?
Who is name?
Manas.
Manas.
Yes. So, n equal to 2k plus 1. So we'll substitute 2k plus 1 in the value of n. So 5 in the bracket 2k plus 1 plus 3 is equal to 10k plus 8, which is even. And we can factor out 2. And so the contradiction, so there is a contradiction, and so we prove it.
It contradicts this assumption. We have reached a contradiction. Therefore, our assumption of not Q is wrong. So what should be right? Q. So 5n plus 3 is indeed even. Clear? Is this clear?
Yes, sir.
All right. All right. So that is question number 2. I'm going to give you the same question, something no harder, but it will be slightly different. Okay. I might make this instead of saying that it is even, I will come up with something that is odd or something. But it will be the same. It will be no harder. I expect you to do it as P implies Q. It's not Q implies not P. What is it called?
Contrapositive.
Contrapositive. And P and not Q implies contradiction. What do you call this? Proof by contradiction. Although they call it reductio and absurdum. I expect all of you to do this. This is the core question in the quiz. So you better practice in the office hour. Good. The third question will be the easiest one in the group. And that is Euclidean algorithm. You will be given two numbers like 341, 527. You take the bigger number and start going. Plus or minus.
Sir, there was the same example as it was in the homework.
Oh, okay. Well, it could be something else then. It will be, I'll give you a different number. The fourth one I will skip for now. And the fifth question is proof by induction. 1 plus 5 plus 9 plus 4n minus 3 equals 2n squared minus n. So here is a statement Pn, which we hope is true for all n. How we are applying principle of mathematical induction. Who wants to do it? Anyone? Okay. Pick a name, Ruhi.
Yes, Ishan. Oh, Vihan. Sorry, Vihan.
Okay, Vihan.
Okay. So it is like so it is not
Yes.
in orders. The natural numbers are not in order. So there are only odd numbers. So not odd numbers. So what we do is now the answer is coming to 2n square minus n. So we take n is equal to k.
Now, first we have to make sure where we start.
Yeah.
Is P1, what is P1?
P1 is 1.
This is the shape of the term. So when you put n equals 1, you get 4 times 1 minus 3. What is that?
So it is 1.
1. Is that equal to this? 2 times 1 squared minus 1.
Yeah.
So P1 is okay. That's where you start. You have to start somewhere. By the way, some formulas are not true for 1. It is true from some, say, n greater than or equal to 4. In that case, where do you start? At n equals 4. That is what we call GPMI, Generalized Principle of Mathematical Induction. Okay? You call it generalized because although it is easy that you can start here, this implies principle of mathematical induction and vice versa. We won't go into that now. Because for tomorrow, all you have to do is check the step 1. Right there, you get 1/3 of the marks. Then what do you do?
So now we have checked for 1. So if we assume that if we take k, so
Assume this is true for k. What is true for k? This formula is true for k.
Yeah.
1 plus 5 plus up to 4k minus 3 equals what?
Equals 2k square minus k.
2k squared minus k. Remember, we are trying to see if this formula is true. So we can assume this. This is the big thing. The reason induction is fast is somebody worked hard and found the formula. They didn't find it through induction, okay? They worked hard and found it through some other way. They gave you the formula. Now you can go ahead and prove it too.
Now
Your job
we have
is easy.
assumed that it is true for k. So now we
you
assume
prove it to be true for
Yeah.
what? For n equals k plus 1.
Plus 1.
If you can show that for k plus 1, this is true, like 2 times k plus 1 squared minus k plus 1, then you are done. We don't know that. So what do we do?
So
Remember,
1
this
plus
is the
5
big.
plus till
So
k.
let's go to the next term. It is 1 plus 5 up to 4k minus 3 and add a term. What is it?
K plus 1.
You tell me. How do I write it properly?
You write it 4k.
Careful. Instead of k, what do I write?
Plus 1.
Plus 1.
Instead of k, I'm going to write what now?
K plus 1.
K plus 1. Watch this.
Oh, it should be in bracket.
Minus 3, isn't it?
Yes.
That will be the k plus 1 the term. Since we have run out of room, let us borrow some space here. Oh, wait a minute. What is the value of all this? By assumption. 8 participants raised the hand. That's what I want to see. One of you tell me, what is the value of that?
K squared minus k.
2k squared minus k, isn't it? The value of this we assumed is 2k squared minus k. Agreed?
Yes.
Let me hear from more people. You see, we have to use the
Yes.
assumption. Yes. So if we use this, right there, a lot of our work is taken care of. All of that is 2k squared plus, what do I write?
K plus
Okay.
1.
K
I mean, K
4 plus 4.
4
Well, we might as
K
well
plus
simplify
1
it. Is it 4k plus 1 actually?
it's just K plus 4K plus 1.
K plus
Because
1
4k plus 4 minus 3 is that. So I done. Now, how am I going to get this into this shape? I don't know. We will see. So this is 2k squared minus k plus 4k plus 1. That is k squared minus 3k plus 1. Hey, wait a minute. I have an idea. Rather than try to get this to be this, let us see if we can simplify this. Is that 2 times? Can you expand k plus 1 squared?
K square plus 2k plus 1.
K squared plus 2k plus 1 minus k plus 1. And that is what? 2k squared plus 4k plus 1 minus k minus 1. It is 2k squared plus 3k. Oh, this was 2. That turns out to be the same thing. Wow.
Excuse me, sir. Vanya has a question.
Yes, Vanya.
So in the last step where you wrote k square minus 3k plus 1, shouldn't it be 2k square?
This here? This
No,
here?
sir. No, below that. The last step.
The last,
The last, the
this,
step you did now.
this here?
Yeah.
Ah,
So the
I
left hand
cheated.
side. The left hand side.
How
The
did
left hand
I get that? Because that is what I want it to be, because it will look like this. Are you with me?
No, sir. The left hand side, shouldn't it be 2k square? Or will it be k square?
Sir, what Vanya is trying to say is the third line from the top, shouldn't it be 2k square minus 3k plus 1? The 2 is missing on the left hand side of the equation.
This here?
Yes, 2k square minus 3k plus 1.
Oh, this one. Oh, thank you very much. So, you need that too. I'm just copying it. And if you simplify this, it turns out to be equal to this. So indeed, this is true for k plus 1. Pragyan, did you follow that? Did you?
Sir. Yes, sir.
Now, Ruhi and Omkar work with them in the office hour on this problem again. They have a little weakness, and it is understandable because they met induction only just yesterday.
Yes.
That brings me to problem number 4, and that is the most beautiful problem in this set. Beautiful.
Sir, there is one more question.
Yes.
Sriram, why don't you ask your question?
Yeah,
Ask
I
me.
did not understand the last part of the fifth questions, please.
Okay.
Something
Ruhi,
down.
can you explain that to the students again in the office hour?
Yes, sir. We'll do
This
that.
is a perfect problem to explain in the office hour.
Right.
Okay?
Yes.
The induction. Okay. Let me go to problem number 4. It talks about something interesting. Bezout's identity. I may not have time to finish this. If so, that's the way it will be. This is so beautiful. What happens is, suppose you have the greatest common divisor of two numbers, A and B. then D can be written as A times an integer plus B times another integer. Let's say D is bigger than 0. Moreover, D is the smallest such number among all the numbers that can be written as AX plus BY. D is the smallest. Let us hold a minute. This greatest common divisor is a very special number. The greatest common divisor of two numbers A and B is the smallest positive number that can be expressed as AX plus BY. Surely you can have lots of AXs and B. You can have A times 2X plus B times 3Y. You can have an infinite number of numbers that are bigger than 0. Among them, the smallest one, what is it? That is the greatest common divisor. Let us prove that. I don't know if we have time. Omkar, Ruhi, should we take 10 more minutes for this?
Yes, sir. No problem.
Yes, yes.
Okay. And you will be rewarded with great understanding, because this is one of the most beautiful objects in mathematics. Okay. Let me see if I have the proof somewhere. If not, I will cook it up myself. So suppose you are given A and B. Suppose D is the greatest common divisor of A and B. Theorem. AX, D is the smallest positive integer that can be expressed. No, I talk too much, I write too much. D is the smallest positive integer of the form AX plus BY. Done. Let it sink into your mind. It is a beautiful object. Look at it. A and B, suppose somebody gives you two integers. They are positive. Greatest common divisor is the smallest integer that can be expressed like this. Why? Proof. Let us consider a set of AX and BYs where X and Y can be positive or negative. And AX plus BY is bigger than 0. I'm trying to construct a set. We still don't know much about that set. I say this set is not empty. A is not 0. They are not 0. I say S is not empty. Because after all, let me take X equals A. And X equals A, Y equals B. Then what is AX plus BY?
A square plus B square.
If A and B are not 0, is this bigger than 0?
Yes.
So you see, there is something in that set. We just found something in that set. Therefore, this set is not empty. Agreed?
Yeah.
We found something there. If you put X equals A and Y, you see, X and Y can be anything. Okay, take X equals A and Y equals B. Then We found something in there, therefore this is not empty. This proof was in a handout I gave you already. Hey, wait a minute. If these are natural numbers, S is a subset of the natural numbers. Why? If these are all positive integers, then definitely this is a subset of the natural numbers. Agreed?
Yes, sir.
This is positive. These are all integers. This set is not empty. So this set is contained in N. What does WOP say?
Smallest number.
This is the smallest element.
S has a smallest element. I will call it D. Okay. And this D, therefore, must look like this. A times some S plus B times some T. Agreed?
Yes, sir.
The smallest element in this set must look like this. Wouldn't it? The smallest element of this set. Where is this element from? Here. So it must look like that. So I write it like that. But then this turns out to be the greatest common divisor. Because try this. Well, it is an integer. It is bigger than 0. Division theorem says I can divide A with B plus some R. Now, I can divide actually, I can divide A with B. B is bigger than 0, I can divide it with B. Now, what about R? I think right now some of you might be a little bit lost. I will come back to you. If I can prove that R is 0, that will mean that A divides, D divides A. If R equals 0, then D divides A. Now, can R be not equal to 0? Suppose R bigger than 0. Then we have R equals A minus BQ, but D is AS plus BT. I am going fast. If I lose you, that's okay, because I will just use the result. This one will be A minus AS, A minus AS plus minus BTQ. That looks like A times 1 minus S plus B times minus TQ. So there it looks like AX plus, hold on. I need room, I need room, I need room. Let me rewrite it. Right now you are lost a little bit. I'm going to get you back. We found D is the smallest element and it is of this form. We are going to prove that D divides A. Then we will prove that D divides B. Then we will prove that D divides any divisor of A and B will divide D. All of that is actually very easy, because how do I show that D divides A? I have to show that suppose A equals BQ plus R is 0. I have to show this. If R is greater than 0, then I have R equals A minus BQ, but D is AS plus BT Q. So this will look like A times 1 minus S plus B times minus Q, which looks like AX plus BY. But R is greater than 0. And if R is greater than 0, and here R is less than B, and R has this form, that means R is in S. This is a contradiction because B is the smallest element. And this is in your notes. You don't have to worry about it. We ran out of time. Therefore, I don't know if I should go back to it again. Should I, Ruhi?
Sir, I think you can do it in 5 minutes, then that's fine.
Well, let's see. I'm not going to repeat this. I just found that if R is bigger than 0, R turns out to be smaller than, being smaller than B, it turns out to be in S and it is smaller than B, but we found that B was the smallest. Therefore, R cannot be greater than 0. Therefore, R has to be 0. Let me see your faces again, guys. We just proved that D is on this form AS plus BT. And let us say that D divides A and D divides B. This is what I proved. I won't go back over it now because we run out of time. But let us say M divides A and M divides B, any divisor. That means A equals what? M times some X, and B divides M times some Y. So I have D equals AS plus BT becomes MX S plus MYT, meaning M times XS plus YT. This means M divides B. So any other divisor of A and B is a divisor of B. This means B is the greatest common divisor. So this is the theory. You can forget the theory for now. The greatest common divisor of A and B can be written as AX plus BY, and it will greater than 0. This is the smallest, D is the smallest number of this shape when you have A and B. So how do you find the Bessort's identity? Question number 4. Let us take 232. Ruhi and Omkar, pay close attention. You are going to explain this to the children. First, you apply. I want to find 232, 136. Oh, by the way, guys, we have finished the core of the course. So this is actually bonus. You don't have to worry, okay? This is the bonus part of the course. I'm going to find the greatest common divisor of 232 and 136. So here I go. It is plus 96, 130. I'm applying Euclidean algorithm. I would like to express what is the greatest common divisor here of these two numbers. Sasha. Oh, Sasha just came in. Vanya, what is the greatest common divisor of 232 and 136?
2.
What is the greatest common divisor of 232 and 136 when we use Euclidean algorithm? The last
it'll be 2.
remainder before 0. Okay? Because what is the greatest common divisor here of 16 and 8?
8. Sorry,
8.
it'll be 8.
And this guy who appears here is always the greatest common divisor. And when we go back, we found that whenever we have A equals BQ plus R, A comma B equals B comma R. So when you go back like this, 16, 16, 8 is equal to 16, 40 equal to, you then go to the next one. What is it?
96,
40, 96.
96, 40. What is it?
136, 96.
136, 96. What is it?
232.
Whoa. Oops. What happened? My screen flipped on me when I am struggling with time. Come on, screen. This screen should go up a little bit, right? Then I can do it. What happened? So 232, 130. You see, this here is the greatest common divisor. So to pick up this greatest common divisor, all I have to do is this. So that is where the Bessort's identity comes in. That is 8 equals, watch this. 8 equals, go back here, 40 minus 16 times 2. Then I go here, and that is equal to 40 minus, what is 16 here? What is 16? 16 is 96 minus 40 times 2. And that turns out to be equal to minus 96 plus 40 times 3. And now I get rid of 40. What is 40? No, what do I get rid of? 40, yes. Get rid of 40. 40 is minus 96. 40 is 136 minus 96. So that is 136 minus 2 times 96. Now get rid of 96. 136 minus 2 times 232 minus 136. And that is 136 and minus 3 times 136 and minus 232 times minus 2. So there is the answer. This is so beautiful. The first time you see, because of the constraint of time, you will think that, oh, this is so hard. It is not. If I say something is easy, it is easy because I am not that smart. If I can figure it out, you can figure it out. What does this look like? This looks like ax plus by. That is the 10-ish.
So like what do we have to write as the answering question for? Like what is it asking for?
Oh, yes. This is the answer I am looking for.
So it's just asking for the identity.
Yes.
Like which we
I
did
wanted
before.
to do, actually, Number 3 and number 4 will be combined. Use Euclidean algorithm to find the Bezout's identity for the GCF of that. So that problem will be one problem. You don't have to do two problems.
Okay.
So what you do will be, oh, guess what? We have a class tomorrow, right? Right, Omkar?
Yes.
Tomorrow's class, we will do this again. So you don't have to worry about it right now. You don't even worry about it. We have one more class. So we will do this exact thing one more time or two more times. We will do it 3 times. And then we'll be done. So we went over this in a hurry, thinking we have no time. I was wrong. We have tomorrow. Tomorrow we will go over this all over again. Does that make you happy? This was the only question we had problem with. Is that right, Shriram?
Yes, sir.
Yes. So, Ruhi, what I want you and Omkar to do will be make sure they can do problem number 2.
Okay.
That is the core of this course.
Yes.
Sir, so will
How to
you do the
approach P
Bezout's
implies Q
identity
3
again?
ways. This problem is not the important one. This one is. So you work on that problem and make sure everybody understands it. Because I will be giving you an exact, just a tiny bit different. I'll change numbers.
Okay.
I am done. And I went over the time by 21 minutes or something.
So there's a question. Ishan, you can ask your question.
Should I answer that question, Ruhi?
Yes, sir. I think you can.
Okay, go ahead.
Ishan.
You may have to help us.
My question is that what is difference between Euclidean algorithm and Bezout's identity?
Ruhi, tell me,
Since we have
Euclidean
two
algorithm?
steps, so what is the difference?
He's asking the difference between the Euclidean algorithm and
Euclidean algorithm gives you finally a 0 here, right?
Yes.
And this guy, this remainder is the greatest common divisor. Agreed?
Yes.
Now, I want you to go back on each step and express this. Remember, we started this as 232 equals 136 times 1 plus 96. If you take this 8 and go back, you will be able to express 8 as 232x times 136y. That's the Bezout's identity.
And what is x and y here?
Pardon?
What is the value of x and y here?
Oh, the value of x and y, we found it. That value can be found using the Euclidean algorithm. When you go back, we had found it. There.
Yes.
X was -2, y was 3. That was a good question. Euclidean algorithm, by tracing back, helps us find this x and y.
But then we have already found the GCF, so why are we again doing this process?
Oh, we have found the GCF. That's good. But if somebody asks you, can you express it as a Bezout's identity? Then you have to trace back so you can express it like ax plus by.
Okay.
Euclidean algorithm has many uses. This is one of the uses. How picking up X and Y, that's one of the uses of Euclidean algorithm. Another use is to express 232 as a continued fraction. I showed you that yesterday. Yes.
Anish, you can ask your question.
Yes, so like tomorrow, like in the test, we need to like trace it back and write the values of X and Y, right?
Yeah, you trace it back and you don't have to write that X equals, you just write this.
Okay, sir.
And tomorrow I am going to do this problem and another problem again, okay?
Okay, sir.
And then it will be clear to you. We went in a hurry today, so we don't have to do it. We don't have to be in a hurry tomorrow. Tomorrow we are very relaxed because we finished all our topics. Okay? And tomorrow, this is the only thing you have doubt about. And we will do that. By the way, you have some notes that I sent your way about mathematical induction. Please read that.
Sir, should we
Ruhi,
do the model test after tomorrow's class or before tomorrow's class?
Ruhi, is that it?
Yeah. So Swasti's question was so I think I can answer it. Swasti, the model paper you'll solve today. Tomorrow, a new question paper will be given for you to solve. Okay.
Yeah, in that model, the question number 1 will be the same. So you memorize it. The reason you memorize it is you need to remember the answers to that question number 1 all your life. So question number 1, you must answer. Question number 2 is P implies Q, not Q implies not P, and P and not Q implies contradiction. Number 3 will be finding Besud's identity. I'm not even going to ask you for separate Euclidean algorithm of two numbers, like I said, 232 and 136, two small numbers. And the fourth problem will be prove using mathematical induction. So tomorrow I will do one problem of this and two problems of that. Will that be okay?
Yes.
That should do it. If I do two more problems of this kind and one of this kind, and if I don't ask you problems that are no harder than the ones that we do in class, you will be fine. But remember, this is the main thing I'm looking for, problem number 2.
Tanish, you can ask your question.
Yes. How long will we have to do the test?
I think 1 hour 15 minutes.
Okay.
So you see, first question should take you only 10 minutes. You spend your time on this one, 45 minutes. This one maybe 15 minutes. And this one maybe 15 minutes or less. So that is already 1 hour 15 minutes. You are going over by 10 minutes. That means I have to make this question very easy. Make it very easy. So this can be 10 minutes. This will do. Oh, here I don't want to reduce that time. So we did 55, 60. We are all. This is 10 more minutes.
So tomorrow we won't have Euclidean algorithm in the test.
The Euclidean algorithm is inside this.
Okay.
You have to do the Euclidean algorithm to find this.
So we won't have a separate question of it.
No, I won't have a separate question.
Okay.
Okay.
Okay? So we will have 4 questions. But spend your time on this. Don't spend more time than needed. You probably wouldn't need that much time. You only need 30 minutes or so. I will give you a very easy question, but that will distinguish the 3 different styles of proving. Okay? Ruhi,
Yes, sir. All
is
the
this
doubts.
fair? Are we unfair to the students?
No, sir. I think we are fair.
I think I gave them too much today. The reason is the course is ending. I want them to have a good course. What did you learn? I learned the fundamental stuffs. I got it all. There's only one topic I haven't covered, and that cannot be covered in, it takes several weeks to cover. That you can do in the university. Predicate calculus. That's logic. You can do that in the university. Right now, I can guarantee you, if you did all this stuff, you are the most prepared, most mathematically advanced students. For your age. Because you know all this stuff. It hasn't been easy. Lot of work. Ruhi, may I go now?
Yes, sir. Thank you.
See you tomorrow, okay?
Yes.
Students, do not worry. Tomorrow we will, the problem number 4, we will do it twice. Problem number 3 twice, problem number 4 once. You'll be okay. Don't worry. If you don't do well, that's because I didn't do a good job. So you don't worry. I will try to make sure I do a good job. See you.
Bye, sir. Thank you.
Bye-bye. Bye-bye.
Thank you, sir.
Bye.